This section introduces the idea of complex numbers, which is something that you may not have covered before up until this class. Okay, so starting off, we're just going to start off with a very basic definition of what the imaginary numbers are. So the imaginary number I is the same thing as the square root as -1. Okay, so we use the letter I to represent an imaginary number or an imaginary root. Okay, generally how you could understand this is we have imaginary numbers because occasionally we'll have the square root of a number that is negative, okay, and which is impossible based on what you understand so far. Okay, so taking the square root of a negative number, up until now, what we would have told you is just say, oh, it's impossible, or we may have said your calculator will give you an error. But there's very important reasons in electronics that we need to be able to do this. So we represent having that negative root with this letter I. Okay, in general, imaginary numbers have the form a plus bi. Okay, there's two parts of this. The first number is the real part. So that's what the numbers we normally use are, like 1, 2, 3, or even numbers like 1.3, 1.29, or even numbers like the square root of 2. All of those are real numbers. Okay, the second part is the imaginary part, or the imaginary root. Okay, so we have the real and the imaginary. So a lot of what this lesson is going to focus on is just how do we take the square root of a negative number. So the square root of a negative real number, or the square root of negative a, that's going to be the same exact thing as the square root of positive a, but again, the negative underneath the square root is defined as I. So it'll be the same thing as taking the square root of a and then times I. And normally we put the I in front just so you're not confused about whether or not it's like under the square root or on the outside of it. Okay, so let's go through some basic examples. Simplify numbers using I. This is going to be a review of what I is and also a review of simplifying square roots in general. So starting off, simplify the square root of -2 by using the imaginary number I. Looking at the square root of -2, we see that negative there. Let's go ahead and rewrite it as the square root of +2 and put an I in front. There's nothing else we can do to simplify this. We're done. Simplify the square root of -8 by using the imaginary number I. So, rewrite it, change it to +8, and put an I in front. So it's I the square root of 8. Next, simplify the square root of 8. There's two ways that we can think about this. One way is to think of perfect squares. Perfect squares. So perfect squares are numbers like 1 squared, 2 squared, 3 squared, 4 squared, okay, which result in 1, 4, 9, 16, and so on. If we can come up with a factor of 8 that's a perfect square, then we can rewrite that 8. So I the square root of 8 is the same thing as saying I the square root of 4 times 2. 4 is a perfect square. So what is the square root of 4 times 2? Well, it's the square root of 4 times the square root of 2. The square root of 4 is 2, so this is really saying 2I the square root of 2. That's one way we can figure out this answer. The other way we can figure out this answer, I'll just copy down that I square root of 8 again, is by using a prime factorization tree. So 8 is the same thing as saying 2 times 4. 4 is the same thing as saying 2 times 2. So any number that shows up twice is a perfect square. 2 times 2 is 2 squared. That's a perfect square. Usually what I do is say to circle the doubles or circle the perfect squares. So we circled 2 times 2. Now the only number left is 2. Question, what about the 4? Well, the 4 is represented in this 2 times 2, so you don't need to worry about the 4. So any double that you circle, it's like saying 2 squared. Take the square root of it. Well, what happens is one of them disappears. So from this 2 times 2 right here, we have a 2 on the outside. We also have an I on the outside. What do we have left? Well, we didn't do this 2 right there. So we're going to leave that underneath the square root. So your final answer is 2I the square root of 2. Alright, so let's keep going. Simplify in practice 1. Simplify the square root of negative 12. First step, it's I the square root of positive 12. Next step, factor tree. 3 times 4. Hopefully you recognize that 4 is one of our perfect squares. We can take the square root of that. If not, that's okay. 4 is 2 times 2. Now, you see these double 2's. Circle them. You see this 3 left over. It's by itself. What do we have? Well, we have 2 from our circles, I from the front, and then it's the square root of what's left over? 3. Okay, simplify the square root of negative 36. First step, I, the square root of 36. Second step, break it up. 6 times 6. Well, hopefully you notice right there you have doubles. Double 6's, you could circle them and finish. Okay, but if not, 2 and 3, 2 and 3. What are your doubles? Well, we have double 2's and we have double 3's. So what's on the outside, what's on the inside? On the outside is 2 times 3 and I, from our I right there. Underneath, nothing's left over, so it's the square root of 1, or we can just leave it. This ends up being 6I. Simplifying imaginary numbers. The key for this, 2 parts. 1, simplify the square roots. Secondly, make sure your real comes first and your imaginary comes second. So let's go ahead and rewrite it. This 6 by itself is the real. 6 plus. Square root of negative 9 is the part with the imaginary. Let's simplify. What is the square root of negative 9? Well, we know it's I, the square root of positive 9. What is the square root of 9? What number times itself equals 9? That would be 3. 3 times 3 is 9. So this is going to be 6 plus 3I. Done. Second one. Square root of negative 18 plus 7. Real comes first. Imaginary comes second. 7 plus square root of negative 18. Next, get rid of that negative by changing it to a positive and put an I in front. Now do a factor tree with your 18. 2 times 9, 3 times 3. Circle your double 3's. The 2 didn't get circled, so it's going to stay underneath. Final answer for this one. 7 plus, you circled the 3's, so it's 3I. You didn't circle the 2, square root of 2. Final answer. Okay, simplifying these imaginary numbers. Same thing. Rewriting it real quick. 4 plus the square root, negative 8. Again, that turns into I, the square root of positive 8. 8 is 2 times 4, which is 2 times 2. Circle your double 2's and rewrite your final answer. It's 4 plus, you circled the 2's, so it's 2I, the square root of that 2 didn't get circled, so 2I, the square root of 2. Done. Okay, pause the video and try to do this last one over on the right. The order did not need to change, but what we could do is put the I in front. So 5 plus I square root of 25, that's going to be 5 plus 5I, and we're done. Flip over to the back, and we're going to look at 2 more examples. Example 5, adding complex numbers. Example 6, multiplying complex numbers. Okay, example 5. This is pretty much the same thing as what we always do when we combine like terms. Okay, now it's going to feel a little bit confusing because you don't remember your distributive property probably. But other than that, it should work out fine. So combine the numbers together, combine the letters together. That's kind of how we do combine like terms. First part, What does this plus do? Okay, this is not multiplication. I say that now because we're going to switch to multiplication later, and I don't want you to be confused. Okay, this is not multiplication. So what do we have? We have 5 plus 7i plus negative 2 plus 6i. Combined like terms. What is 5 plus negative 2? 3. What is positive 7i plus 6i? Plus 13i. That's it. Nothing real complicated. Make sure your numbers come first, your i's come second. The second one, a little bit complicated. This minus sign in the middle needs to get distributed to both parts of the second binomial. Minus 2, minus 4i. So what do we have? We have 8 plus 3i minus 2. Okay, minus a positive 4i is minus 4i. Okay, now again, combine your like terms. 8 minus 2. 6. 3i, a positive 3i, minus 4i, minus I. Done. Okay, these practice are up to you. Example 6. Multiplying complex numbers. Simplify the expressions. Well, you need to remember this one thing. If I is the square root of negative 1, that's what our earlier definition, what happens when we square both sides? So I squared equals the square root of negative 1 squared. Well, when you square and square root, they cancel each other out. So we find that I squared equals negative 1. That's how square roots and squares work. They are inverses of each other. So, how does this work for simplifying these expressions? Well, at the beginning, what you do is simplify it like you would if it said x. 5i, negative 4i, that's like 5x times negative 4x. Multiply the numbers, 5 times negative 4 is negative 20. I times I, just like x times x, is I squared. That's pretty much it. Now refer back to this definition. I squared is equal to negative 1. So what I'm going to do is substitute out this I squared for negative 1. So it's negative 20 times a negative 1. Well, what does that give us? All it really does is changes the sign to a positive 20, and we're done. The second one is multiplying two binomials together, which we do using the FOIL method or the box method. Okay? If you use the FOIL method, that would be the first two numbers times each other, then the first number times the outside number, then the two inside numbers, then the second number times the second number. So 6 times 4 is 24. 6 times negative 3i is minus 18i. Negative 5 times 4 is minus 20i. Negative 5i times negative 3i is plus 15i squared. What can we simplify? Well, we can combine these like terms in the middle, which I highlighted in yellow, and don't forget, I squared is equal to negative 1. So rewriting this line, we have 24, negative 18i minus 20i, just add or subtract those numbers, minus 38i. 15i squared, remember, I squared is negative 1, so that's plus 15 times negative 1. So, what'll combine now? 24 plus 15 times negative 1, or 24 minus 15. That is going to give us 9 minus 38i. Okay, I'll do one more. This last one on the bottom right. Multiplying complex numbers. Box method this time, in case that's your preferred method. So, on the top, it's 4 minus 9i. On the side, it's 4 plus 3i. What does that give us? Well, the top left box of 4 times 4 is 16. Top right, negative 36i. Bottom left, 12i. Bottom right, negative 27i squared. In this, what usually happens is that the top right box of negative 36i and the bottom left are going to combine together. So we're going to have 16 minus 24i minus 27i squared. Okay, what changes? What changes is that this I squared is a -1. What is that really going to change each time? Well, go to the sign that's right before the I squared. So the term that has the I squared. And really what that I squared is going to do is just change that sign from a minus 27 to a plus 27. So it's going to be like 16 minus 24i. Instead of minus 27i squared, I squared changes the sign. So it's just plus 27. So what is 16 plus 27? Well, that is 43 minus 24i. And you're done. Okay, so you can look at some of the homework problems on the next page and work your way through them. See if you can figure out how we would solve using this.